Hello and welcome to ECMath. Today we're going to look at how to solve the Math 3 problem called Ming's New Maneuver. And just one quick word on how to use this video. I kind of expect that you have attempted this problem prior to watching this, and you're only watching this because you're either stuck or you want to check your results. Watching the video is not a substitute for actually trying the problem, so I really encourage you to try and work along with me or play along at home. The problem's right here. So without further ado, let's get into it. This is a story about surfer Ming, who I believe is a character in a number of problems, has finally perfected the two bride and wants to use it with her off-the-lip moves and cutbacks in her next competition. The waves at this new beach are well suited for this move, but Ming cannot do the same move over and over because she still needs to plan her ride to maximize her points. Nothing in these two paragraphs is important for this problem. This third paragraph has some interesting information. In this competition, Ming must make exactly 20 moves. Also, because the sponsor of the event is a lipstick company, she is required to do at least 3 off-the-lip moves. So this feels like we're getting actually 2 constraints right here. Before we get to constraints, we should define some variables, and it appears that she's doing 3 kinds of moves. It looks like from the first paragraph that she's doing 2 brides, off the lip, and cutbacks. So let's do T for the number of 2 brides, L for the number of off the lip moves, and C for the number of cutbacks. These are all real surfing moves, by the way. You can look them up. Now we're ready. So this is the total number of each kind of move, and that feels like a good variable because everything else in the problem is going to depend on how many moves she makes. In this competition, Ming must make exactly 20 moves. I'm going to call that constraint A, and since she must make exactly 20 moves, and each variable represents the number of moves, then the system we're going to make is T plus L plus C equals 20. She has to be exactly at 20, and that's a really important piece of information in this problem that I'm going to highlight now, and we may come back to look at later. She is required to do at least 3 off-the-lip moves, so I'm going to call that constraint B. We're going to say L, the number of off-the-lip moves, is greater than or equal to 3. Ming decides that she should use at most 24 seconds for her 2 brides and cutbacks. So let's go ahead and start writing a constraint less than or equal to 24. And I'm going to make a note that this is seconds. Why? Because on the other side of the equation, the things that I put here also need to be in terms of seconds or have to involve the time. She used 24 seconds for her 2 brides and cutbacks. It doesn't say anything about the off-the-lip moves. Maybe in this story, the off-the-lip moves don't take enough time, or she's going to use the rest of the time for her off-the-lip moves. It's unclear, but lip moves are not specified here, so we're not going to include them on this constraint. She also figures that the cutbacks will take 1 second each, and the 2 brides will take 2 seconds each. So if the cutbacks take 1 second each, then for every cutback she does, she's going to do like 1 second. So 1C, or just C, is a good constraint for cutbacks, plus 2 T for the number of 2 brides. And that must be less than 24 seconds because she can use at most 24 seconds, so we have less than or equal to. And we can double check this constraint. This is the hardest one to write. 1 second per cutback, 2 seconds per 2 bride, then we multiply those together and then we add them all up to get the total time. That's all less than 24. So this top one's about total moves. This is about the total of off-the-lip moves. This is about the total number of seconds. Now there are 2 more constraints we need to add. We're doing T, then L, then C. So we need to make sure that T is greater than or equal to 0. Normally, we would need to make sure that L is greater than or equal to 0 as well. However, we already know that L is greater than or equal to 3, so we do not need to include that L is greater than or equal to 0. Instead, we just need to include that C is greater than or equal to 0. These are our 5 constraints. So we have 3 variables, 5 constraints. We're ready to start solving our system. So that's part 1 in the problem in the book. Set up a system of constraints for the problem. For L, C, and T, they tell you what variables to use. Now, we need to determine how many type of each move Ming should make, and to do that, we are going to go into a table and start using our calculator. Before that, I realize my variables are kind of out of order of the way the book is specified, so I'm going to take a second and reorder my variables to be in that L, C, and T order, which is probably what most of you had when you did this in class. Okay, those have been reorganized in L, C, T order. It is important here. It doesn't necessarily matter what the order is, but it's important that you're consistent, because when we go translate this into matrices, you're going to need things to be in the same nice order. And perhaps importantly, when I switched the order here, I did switch the order of constraint D and E. I had T up here, and I moved it down here. So just be aware of that. All right, I think I'm done with the problem, except for the objective function. I haven't looked at anything with relating to points. Now, since she's trying to maximize her point total, then let's write the equation for points as 1 point for each off the lip mover, 4 for each cutback, and 5 for each tube ride. Get that. Oh, there. Get that over in the nice spot where we can all read it. So that'll be our points function, 1L plus 4C plus 5T. Points, by the way, not a variable, and 1L, 4C, 5T are not constraints. Those are data about the problem that help us create the objective function, but it's not one of the things that I would consider a variable or a constraint. All right. Now I'm going to close my problem and show you, reveal a blank spreadsheet. Now you might be used to doing this in a table, but I'm on the computer today, so I'm using a Google Sheet. I'm using Excel, but you can do this in Google Sheets also. And that's going to really help in the final step. We'll see why. So we've got our variables. Now, in this first column, I'm just going to write the possible groupings of variables. This is a 3-variable system, LCT. So I need to take these constraints in groups of 3. Because to solve an equation in 3 variables, I need 3 equations. So the first constraint group would be A, B, and C, for example. And then A, B, D. Now I go to the ACs. Now the ADs. And now I'm exhausted all of the A options. So let's go to B. I've done all the BCs. Let's do all the BDs. BD and E is left. And that's all I can do with B's. But there's one last constraint group that I can do, which is C, D, and E together. So these are the 10 constraints. If you do the little factorial math that you may or may not have seen, then that checks out. There should be 10 constraints. I'm going to label my columns: lip moves, cutbacks, and tube rides. I will use these other columns, but we'll just leave them alone for now. And I'm just going to record my solution points in each of these spaces. Now, I'm going to use my calculator with matrix feature to solve most of these equations. I'm going to show you all the steps, but I'm using my Inspire because it's a little faster for the video. Your TI-8384 can do the exact same thing with the matrix menu using the same commands. It's just going to be a little faster when I have to do 10 repeated ones and I can't split it up with a partner. So here we go. I'm going to do menu matrix. I'm just pressing 7 to get matrix, and I'm going to set up RREF first. Now all of these are going to have 3 equations and 3 variables, so I need to add a matrix. Where are we? Create a matrix that is 3 by 4. There I am. So I've got this command, and I'm just going to re-edit this matrix every time. For the first one, I need to do constraint A, so I'm going to do grouping ABC. Constraint A is LCT equals 20, so I do 1L, 1C, 1T equals 20. Then 1L, 0C, 0T is equal to 3. And I'm going to do constraint C, which is 1. Nope. No off the lip moves. 1 cutback. 2 tube rides is less than 24. So being really careful in the system, a lot of room for error with missing zeros or missing pieces. This is what this should look like. We get the solution set for LCT. L is 3, C is 10, and T is 7. By the way, if you are watching this and you're not in my class and you learned a different way to solve systems with matrices, use that method. Everything works. I'm using the method that works best for me, but if you've learned how to solve this as an equation using the A inverse and B command, that's fine too. It really doesn't matter. You get the same thing either way. This is just the way that I like to do them, so that's the way I'll be showing you because it is pretty fast. Now, I'm going to do intersection ABD. And what's really nice about doing them on the Inspire this way is I've already got A and B already in here, so I just need to change this to constraint D. So constraint D said that if C is 0, so the constraints are in order L, C, T. This is 1C plus 0T equals 0. So be really careful about how you're going to enter those 0 constraints, but right, this 0 constraint is 1C, and that one is 1T. So that's going to enter on a matrix as 0, 1, and 0, and 0. Not in a whole row of zeros, because if you do a whole row of zeros, it's not actually saying the constraint, it's just saying 0. All right, so we enter that. We get the solution set 3, 0, and 17. Let's do another. So I scroll up, I grab that guy. I need to change to constraint E, which is T equals 0. So for that one, I can just get rid of U and put a 1 there, and we get 3, 17, and 0. Just kind of makes sense. Think about the way that we're switching the variables around, that we're just switching which one has 17, and off the lip still have 3 because it was part of constraint B. All right, from here on, I'm going to hopefully speed up the video a little bit, so I'm going to stop talking and just solve the remaining 10, but I will show you all my matrix work. So I'm going to do ACD now. That's why I use a spreadsheet, so I can undo when I mess up. All right, now notice I got a negative result here, and that's actually fine because notice that this A, C, and E did not include the constraint that specified that L must be greater than 3. We're going to cross that out at a later time, but for now I'm just going to record that result in here, noticing that, right, it still adds up to 20, just like constraint A specified. It just happens that since we didn't have constraint B, the negative wasn't, forced to be positive in this case. But when we do this step here, where we check everything, then we'll figure out that this violates things. So I'm going to leave it for now. All right, switching over to A, D, and E. Just doing all 20 of one kind and 0 of everything else. If I'm being honest, I probably could have solved that by hand because this is just saying C equals 0 and T equals 0, so L must be 20. If I was being really sneaky, I would probably not do all of these with the matrix. In fact, why don't I go look at C, D, and E? Well, let me see if there's any ones I can figure out. How about B, D, and E? Right here has to be 3, 0, 0. Let's see if there's anything else we could figure out by hand. Anything with D and E seems like that'd be really easy to figure out by hand. Like C, D, and E. If C is 0 and T is 0, and everything is less than 24, this is actually going to give us a weird solution. So maybe we will do that on the computer. Now let's just try BCD now. So I got L greater than 3. I go back to my matrix, and I got 1L, 0 those, 3. C is 1C, 2T, 24, and D is 1C, 0T is equal to 0. Alright, so we got 3, 12 here. Let's look at B, C, and E. B, C, and E. That should be a quick change because I just need to change the last line. 3, 24, and 0. And C, D, and E. Let's check that in. So I already got constraint E down here. So if I make that a 0 and that a 0, that's constraint D, and then constraint C is 0, 1, 2, and 24. Now, take a look at this. We got our bottom row is all zeros but equal to 1. So that's a problem because that means that this is saying 0 equals 1 as an equation. If you did this on a using the other method, A inverse B, you'd probably get an error here. So let's take a hot second and actually look at what's going on. This is saying C equals 0, T equals 0. We can plug 0 in for this and this. That is definitely less than, it's not equal to 24, right, if we're solving this equal. And there's no information about L, so C, D, and E is actually no solution. For all of them. Actually, it's weird. I'll just write it like this. So again here, I'm mostly working with the matrix on the calculator because that is my fun new tool. There's none of these that you couldn't solve by hand. These are all pretty reasonable, if I'm being totally honest, especially because there's 3 constraints that are super simple. But it's also good practice in using the matrices. If you are using matrices with these simple constraints, just really watch out for these rows of 0s and 1s. And just try to keep things ordered, have an orderly process, because if you mess up and have the wrong constraint, it can be hard to detect your mistakes. It's also nice if you're doing this with a group to have a group mate check you. All right, so speaking of checking, that's now the next step. And when I say check, here's what I mean. Every system must satisfy all 5 of these constraints. All 5 things must hold true. Now, because, for example, line 2 came from solving the system with A, B, and C, I know that those 3 are already going to cause this to be true. That is, 3 plus 10 plus 7 is definitely equal to 20. L is greater than or equal to 3 because it is 3. And 1C plus 2T, so 1C is 10 plus 2 times 7 is 14, is exactly equal to 24. Those constraints will be satisfied. So I just have to check the missing constraints, D and E, which are both specifying greater than 0. These are okay. I'm going to say okay. If it's not okay, I'm going to make an X and say what constraint was violated. A, B, and D, I have to make sure this satisfies constraint C. And looking at this, I actually noticed that it doesn't, because 2T, 2 seconds per cutback, this would be 34 seconds. Plus, the alpha lip moves don't even matter for that constraint, but that breaks constraint C. So I'm going to say X, and it says breaks constraint C. So that's a problem. Whoa, what are we doing here? All right, no parentheses. We'll just say C. X violates C. We can have a little more space in our spreadsheet. There we go. What are we going to do? Make that a little smaller, make that a little smaller so it all fits on screen. Okay, make that a little bigger. A, B, and E, so we need to check this against constraint C as well. Now, this one seems fine because 1C, which is 17, is less than 24, and everything is positive. So this is okay. A, C, and D, 8, 0, and 12. A, so this needs to check with constraint B is missing, and E is missing. Well, E is fine, everything's positive, but what about constraint B? Is L greater than 3? Yeah, it actually is, so this one's okay as well. A, C, and E, -4, 24, 0. That -4 is a real problem. We said that L must be greater than 3, so we're going to say X, and that violates constraint B, which said that L had to be greater than 0. A, D, and E, 20, 0, and 0. This is probably going to be okay. We need to check it against constraint B. L is greater than 3 because 20 is way bigger than 3. And 0 plus 0 here is okay because it's less than 24, and the time constraint didn't really apply to the off the lip move, so this is okay. Might not get her very many points because the off the lip moves aren't worth very much, but it is technically a potential corner. Now let's look at some of these other ones. B, C, and D, we have to check against constraint A. So constraint A is a little more restrictive than the other constraints. It has this equal sign. Now, so I really just have to check, is 3 plus 0 plus 12 equal to 24? No, it's not. So this violates A. That's not how you spell that. Now, B, C, and D, is 3 plus 24 equal to 24? No, that also violates constraint A. And is 3 plus 0 plus 0 equal to 24? No, that violates constraint A. And C, D, and E already had no solution, so I don't have to do anything. Now this check is really important, like unbelievably important to check that which constraints satisfy and which ones violate other things. If you're not doing this column, you're not solving the problem, you're just doing a bunch of random algebra. This is what we mean by finding the actual corners of the feasible region. These are the 4 points that if we were able to graph this region in 3D, those would be its corners. All right, so what's the next step? Well, the next step is the objective function. All of these 4 surviving points, right here, put those in bold, we need to check the objective function. Now, I'm in my spreadsheet, so I'm going to do something really cool. Check this out. I know the objective function is 1L, so I'm going to do equals 1 times asterisk, I'm going to click the number of off the lip moves, plus 4 asterisk times the number of cutbacks, plus 5 times the number of tube rides, which is in cell D2. This is this Excel formula. You can use this in Google Sheets as well. That'll tell me the total number of points. Now, the reason we do this in a spreadsheet is you can actually copy that and paste it in different cells, and it will update. I could do it in these other cells, but they already violated constraints, so I'm going to keep things simple and observe just the points, or just do the points for the things that I need. Now, that's really cool. It wouldn't take that much longer to do it by hand, just do it in your calculator, but I don't know. I'm here, I'm doing it my way. And I can see already that that cell is the winner. So I'm going to summarize the result. Ming should perform 3 lip moves, 10 cutbacks, and 7 tube rides for a maximum of 78 points. So that's kind of our solution to the problem. And one last thing I wanted to highlight here, a really important lesson, is look at what constraint was violated most often. It was constraint A. In fact, anything that didn't have constraint A was not a solution point, and all solution points had constraint A. And that is specifically because it had that equal sign. When we solve further problems, this one you didn't really need any more tricks, there were only 10 combinations. When we solve more complicated problems, constraints with equal signs will always be required in the grouping. We can talk about more of that in class, but constraints with equal signs will always be required in the grouping because they are a little more restrictive than just the inequalities. All right, folks, that's all I have for you today. Thanks for sticking around and watching. I hope this helps you understand how to solve Ming's new maneuver. Please ask me all the questions you need to, and I'll see you all next time.